Before we start, let us first define what SHA-1 or Secure Hash Algorithm 1. So it is referred to a cryptographic hash function that is proposed by United States Security Agency. It takes an input and produces output of 160 bits hash value. Furthermore, the output produced by this function is converted into 40-digit hash long hexadecimal number. So we have here, we draw the pattern of the SHA. So we have the babe, SHA-1, and the hash value. So the example we're going to use is babe. The capital B and the rest is the lowercase. Let us first find the binary of each letter. Let me show you first the binary of uppercase letter from A to Z. And here are the lowercase of a letter. So, now, let us find the binary of babe. So, here the binaries of each letter. So, the first one is B, capital B, 0, 1, 0, 0, 0, 10. And the lowercase of A is the 0, 11, 0, 0, 0, 1. And the letter B is the 0, 11, 0, 0, 10. And lastly is the E, that is 0, 11, 0, 0, 100.
Now let me show you the hexadecimal of each letter. We have B, 42, A, 61, B, 62, and E, 64. Here are the 5 random strings of hex characters that will serve as a part of hash function. We have H0 to H4. When H0 is equal to 0x67452301. And we have H1 is equal to 0xEFCDAB89. And H2 is equal to 0x98BADCFE. While H3 is equal to 0x10325476. And the last is we have H4 is equal to 0x C3D2E1FO.
In padding the message, 4 characters which is BABE times 8, which is their binaries is equal to 32. So the message contains 32 bits. To make the message become 512, the message will be faded by 1 bit. 448 minus 32 plus 1 is equal to 417. Since the message is 32, we will be adding 416 to become 512. And it will look like this. These are the binaries of the letters BABE. The independent one. And we will add 417 zeros to become 512 blocks size.
The padded input above is then divided into 512 chunks, and in chunks is further divided into 32 less bits worth. W parenthesis to 0 less W parenthesis to 15. Each chunks begins the 80 iterations necessary for hashing and execute the following step. For iteration 16 through 79, where 16 less than or equal to I less than or equal to 79, perform the following operations. So here are the operations to be used. Now, store the hash values defined in step 1 in the following variables. Letter A is equal to H parenthesis to 0, B is equal to H parenthesis to 1, C is equal to H parenthesis to 2, D is equal to H parenthesis to 3, and last, letter E is equal to H parenthesis to 4.
For 80 iteration, where 0 less than I less than 79, compute. See below for details on the logical function. And on the values of K, resign the following variable: E equals to D, D equals to C, C equals to S, close open parenthesis, B equal to A to attempt. Store the result of the chunk hash to the overall hash value of all chunks as shown below and proceed to execute the next chunk. As the final step, when all chunks have been processed, the message digest is presented as a 160-bit string compressed of the OR logical operator of the 5 hash values, so the string base becomes represented by a hash value base.